Welcome to Khetz tutorials, and in this video I'll be doing question 1 from 1.3 exercises in James Stewart calculus. So the question says, suppose the graph of f is given, write equations for the graphs that are obtained from the graph of f as follows. So we're applying each of these transformations to the graph of f. So let's just call it f of x. So this is our original function f of x. Now let's apply all of these things. Let's start. So first we're going to shift 3 units up. So it's going to go up. So that affects the y. And remember that f of x is y. So our new graph would be y equals f of x plus 3 because we're going up. So if you want to shift y by 3, you're going to add 3 to all of the y's, and that's how you do it. Then the next says shift 3 units downwards. So this is the opposite of what we just did. So we're going down. You're going to subtract 3 from each y coordinate on the function. And the third one says shift 3 units to the right. So when you do a right shift, it's actually going to be f of, so it affects the x. You're going to go to the right, and that's how you go to the right. And when you shift 3 units to the left, it will have the opposite sign. So we're still affecting the x because left and right affect these directions, and that will be your x values. That's how they change. And with this one, just be the opposite side. So we're going to the left. The next one says reflect about the x-axis. So when you reflect about the x-axis, this will be the x-axis. Imagine a dot there. This is the x-axis. If you reflect it, it's going to come this side. If you look at this, the x remains the same, but whatever the y here was, let's say it was 2, now it's minus 2. So in other words, we negate the y when we reflect about the x, and when we reflect about the y, we negate the x. And you can figure it out as well. If you have the y, a dot there and another there, the y stays the same, but this negative x now becomes a positive x if you reflect about the y. So in E, we're reflecting about x, so we're going to negate our y. And if you negate the y, we just have this, and f of x represents y, so we're going to negate it. Then with f, we are reflecting about the y, so we're going to negate the x. So that's why we have a negative x in there. Then for the next question, we're supposed to stretch it vertically by a factor of 3. So stretching vertically basically means you're making it bigger, and that requires us to grow our y values. So if you grow our y values by a factor of 3, this is what the function would look like. And finally, we asked to shrink it. So we're going to make the y values smaller. So for example, if you have a trig function or even a parabola, or let's just use a trig function, I think is the best option to use as an example. This would normally be at 1 and minus 1. And now if you multiply that by 3, we stretch, so it'll be bigger. It will not be at 3 and minus 3. Multiply by 1 over 3, which is what we're going to do for the last question, to shrink by a factor of 3. This is what it would look like. Then it'll be at 1 over 3 and minus 1 over 3, so it'll be much, much smaller. Basically, it influences the amplitude or the size of the graph. So these are all the transformations applied to some original function f of x.